No. Different species of chip is different. Dr. Wine, do you still have the little sign-up sheets for the scientists?
Not here.
Not here. Okay. So I'll probably do that afterwards. Okay. Yeah, I guess the office.
Oh, I should have got down here. Going.
You don't need to share it. Yeah. So we'll see how well it is.
Oh yeah. I sent you slides and they were like, and then I saw all of them. They don't match at all. So I sent it to you like that.
Okay, I haven't looked at my email recently. I've been working on a report and other stuff. I have a report due.
First, but a lot of people are doing it. Yeah, I really need to get it done. That's how we know the report now. We get on Thursdays. I'm like, great. I didn't realize it was so sitting, we'll have to report outside. Yeah, I have a variety of food there. Be relatable. I know. You. I sent you my food here, my bear food. Don't be alarmed when you use like 7 from me. Okay, but it's probably just, I think it's 3 actually. 1 and we can do like all of them. I have no shame. No, well, I use it. Senior. I basically I'm coming back. Oh, that's okay. I think because you should know.
Ding dong, ding dong. Ding, ding, dong, ding. Ding, ding, dong, dong. Prevalence that I am. I am Lucy. I am. I am.
Okay, folks, it's that time of the day. Lots and lots of announcements to make.
I think go far. First, as just reminding you, you do have a quiz due tonight. I'm just letting you know it's going to be, I gave you a full hour. It is a titration problem. It's a single problem with multiple parts. Now, because of that, this entire active does not like me because it wants to give the entire question 10 points. However, Jibby, I did want to let you know that I will be going back into it. And if you got 4 parts out of 5, you'll get 8 out of 10. So I'll be going back and giving points. So don't freak out because I will be going back in and doing partial credit. It just doesn't know how to do it apparently, at least that's my experience. So that's due tonight at 11:59 p.m. You have your KSP lab from last week. It's due at the start of class Wednesday. On Wednesday, you also have 2 ed puzzles that are due. They are related to thermodynamics lab. They are the procedure for the thermodynamics lab and the math associated with the thermodynamics lab. So it's going ahead and watching the procedure may be useful because I know in there I can get some, I've given a couple of hints to try to keep this from taking too long. Because what we're doing is we're taking a saturated solution, we're heating it up till everything dissolves, and then we're cooling it all the way back down, heating it up, and it keeps going for 5 times. So that can take a lot of time if you talk about hot water trying to cool it off. So pay attention. And then the math, I noticed some people are getting the gist of the reason the math is in there. It's very handy when you're actually doing the lab to go in there and basically be able to see the math in case you have any questions. Homework due on Sunday, 11:59 p.m. There are also 2 methods, math, chemistry, and puzzles, and you can actually go ahead and do those anytime you have time, because they are strong acid, strong base titration and a weak acid, strong base titration. So 2 things that I did last week. Now, with respect to these, again, they are ones that I have to physically go in and grade. So it's not going to come up with your score automatically. I have to go back in after they're due and go in and check all of them. And I still give partial credit, yes. So, probably tomorrow or Wednesday, you're going to have 2 columns pop up, unless you need to know the information today. By the way, I forgot to put it on it that today is the W deadline. So if you are withdrawing from any course, it has to be today. But I do have 2 columns I will have popped up. One of them is total points with drops. That means I've dropped your lowest test grade, your lowest 2 quizzes, your lowest 2 homeworks, your lowest lab grade. And the other one is a no test drop. So I've dropped the 2 quizzes, the 2 homeworks, and the 1 lab, but I've not dropped the test. Those are the 2 options I gave you last week. One, you have to take the final. The other one, if you like that grade, you don't have to take the final. Now, I wanted to take a moment. I think I said this to a lot of people on Thursday, but I wanted to wait until I said it to everybody. And that is the reason I have not put these up yet is because they can be a little bit misleading. The way the Blackboard is set up to do these calculations, it's going to only assume things you have grades for. So, for instance, if your lowest test was this class test, it's currently dropping it. But let's say you were to make lower on the next test. Then after I input that grade, it'll go back and re-add this 3rd test and drop the 4th test. So it's going to be in constant flux. So you have to be knowledgeable of that issue before I just post those grades. And that's why I'm always hesitant to do too much of that, because people will freak out due to the fact that it's doing this number a lot. And it's all dependent upon what grades are in there. And I'm talking about what physically has a numerical value. So if you look on there, I've got columns right now for all of your labs. They don't physically have a numerical value yet. It's not incorporating those. It only incorporates what it has a physical numerical value for. So keep that in mind, but I will release it, and that way you get an idea. So you'll see 3 total columns. One is all of your points, no drops. I should say everything but the lab ed puzzles. One of it will be total points with the test drop, and one will be total points with no exams dropped. So just trying to go through that. Just a couple of quick other things. Number one of your last few bonus opportunities occurs tomorrow at X period in the Math Computer Science building in 110. That is 5 points. You go in, you take notes, you bring me the notes on Wednesday. It can just be handwritten notes. They don't have to be anything overly crazy, and you'll get your 5 points. There are the due 421. There are 2 things that are due, so a week from Friday, and that is the famous scientist and the Bear Food Pantry. Those are each worth 10 points possible, so keep that in mind. There is one other bonus opportunity that I do not have listed. It's not until the last week of classes, the Wednesday before study day. And then finally, I just wanted to mention the fact that I haven't had a whole lot of people come to study sessions. So instead of having a study session in a classroom away from my computer, I'm moving it back to my office. That way I can be doing stuff. Now, if I get a ton of people, we'll move someplace where I can work with you. But until I get that, I need to be, I don't want to sit there and not be able to get a hold of everything that needs to be done. So, any questions? Trying to think if I forgot anything.
About your office hours,
I
don't remember when they are, but I just remember I think they're frequently conflicting with my schedule. Are you available to schedule something outside of your normal hours?
Oh, by all means, I am. Basically, if my door's open, it's an office hour, whether it's an official office hour or not. My official office hours are 1 to 2 today and 2:30 to 4:30 tomorrow. But literally, if you find my door open, you're welcome in. Doesn't matter what time. The only day that's really bad, the only day I can guarantee I'm not in my office at all is Thursdays. But otherwise, I'm usually pretty good about being in there a lot. So. And I even get here at 6:45 most days. So if you really need an early appointment. Any other questions? Okay, then what we'll do is I'm trying to think, there was something else I was going to, and it has slipped my mind. So I'll go ahead, and if I think about it, I will mention it. But so today what we're going to do is we're going to start with a weak base strong acid titration. So in other words, the reverse of what we were doing last Wednesday. And then we will move on to doing simple KSP calculations before we get into common ion effect on Wednesday, and we will start getting into entropy on Wednesday. So that is the overall plan. Now, last Wednesday, we talked about a weak acid, strong base. And we talked about the fact that the incline is much shallower than it would be with a strong acid, strong base titration. We talked about various points along the way. This first point represents the weak acid in water. So you're going to be able to calculate the hydronium concentration the way we did prior to the last exam. And from that hydronium concentration, you're going to be able to determine the pH. Now, this first region is called the buffer region. Within the buffer region, remember that you do have to take into account dilution. You will then determine the weak acid conjugate base concentrations using an ice table. Sorry, my thing's acting up. And then you use the Henderson-Hasselbalch. Which is pH is equal to pKa plus the log of the base over the acid. Now, at point 3 along the, let me actually back up. There is a very specific place along this that is very, very nice. And that's point 3. Point 3 is known as the half equivalence point. And at the half equivalence point, the reason it's so nice is that the pH is equal to the pKa. Basically, you're halfway to the equivalence point. Literally, that's what it stands for. You're halfway there. Now we will go for the equivalence point. So the fourth area is our equivalence point. You have to start with dilution calculations. But when you use an ice table, you will see that only that weak base is the only thing present. Because the weak base is the only thing that's present, that's when you take that weak base and toss it into water. By doing so, you're going to determine the hydroxide concentration, which is going to allow you to determine the pOH. And then finally, you can get to the fact that 14 is equal to the pH plus the pOH to get to the pH. The fifth region. The fifth region is where you will have excess strong base. The first thing you will be doing is you will still be doing a dilution calculation. You can then use an ice table or BCA. They're basically very similar. And that is going to show you that you have strong base and weak base present. The fact of the matter is our the weak base, or we're going to be able to get to our pOH by taking the concentration of the excess weak base. I'm sorry, excess strong base. And from that, we will get out our pOH, which then we can use 14 is equal to pH plus pOH to get to pH. So these are the 5 regions of a weak acid strong base titration. Now, for today, what we're going to be doing is we're going to start with a weak base and we're going to add strong acid to it. If I could just draw. Again, just like with the weak acid strong base, you will notice that the incline is much shorter. Folks, we still have essentially the same regions. The only difference is really region 1 and 4. Well, 1, 4, 5, I guess, but 1 is a weak base in water. Meaning you're going to calculate determine the hydroxide concentration using the equilibrium expression, convert that into the pOH, which you will then use 14 is equal to pH plus pOH to get to the pH. Area 2 is still a buffer region. Folks, area 2 is the same as for the weak acid strong base section. Treat it identically. Area 3, which is that half equivalence point, is still the same as that of a weak acid strong base. Area 4, which is your equivalence point, you're going to start out very similar, meaning you're going to have to do the dilution calculations. You're going to have to use an ice table, which will allow you to determine the concentration of the weak acid. You're going to take that weak acid and you're going to toss it into water and do the acid dissociation, which is going to allow you to determine the hydronium to get to the pH. And then 5 is essentially the same, except now you'll have excess acid. So you're still going to do the dilution. You're still going to use ice table to determine the excess strong acid. And technically the weak acid. But then you will basically use your, you'll use that excess strong to determine the hydronium, to determine the pH. They're essentially identical, but you got to think of what's present. But if you can do the math for one, you can do the math for the other. You just got to think in reverse. So that's what we're going to do. Consider the titration of 100.0 milliliters of 0.200 molar CH3NH2 by 0.100 molar HCl. Calculate the pH. After 0.00 milliliters of HCl. After 20 milliliters of HCl, and at the equivalence point. The KB for CH3NH2 is 4.4 times 10 to the minus 4. I'm going to let you do part one by yourself. Man. Okay, so with A, you just had base and water. So that's why I wrote the reaction the way I did. I took the methylamine, I added it to water, which made the methylammonium ion and hydroxide ion. According to the information we were given, we had 0.2 molar methylamine. And because this was without any hydrochloric acid, that means we had, that's all we had. So we allowed the methylamine to dissociate. So minus X, and we created X amount of methylammonium and X amount of hydroxide. So at equilibrium, you had 0.2 minus X of the methylamine and X of the methylammonium and X of the hydroxide. This is a base, so we needed the Kb expression. And so the Kb would be equal to the methylammonium ion times the hydroxide ion all over the methylamine concentration. The Kb was given at 4.4 times 10 to the minus 4. That would be equal to X times X over 0.2 minus X. Multiplying through by the denominator, you see what I get, and rearranging so that I get 0 is equal to X squared plus 4.4 times 10 to the minus 4X minus 8.8 times 10 to the minus 5. Using the quadratic equation and solving, you get an X of 0.00938. Now, you have to pay attention, folks. I noticed this on the last exam. You've got to pay attention as to what you're dealing with. Our X is equal to our hydroxide. Whoops, cancel? No, chill. I know, it's his keys again. So that means that we can get the POH from that information, because the POH would equal the negative log of the hydroxide, which is equal to the negative log of the 0.00938, which is where I get the 2.03. And then you have to use the equation that 14 is equal to pH plus POH to get to the pH. Questions about the first one? Okay, so at this point, I'm up to B. Well, before I can really do B, I mean, I could do B without it, but the easiest way to do B for me and to think things through is to know what the equivalence point would be. So I'm going to do some stoichiometry first. I have 100 milliliters of my methylamine. Or 0.1000 liters. That is a 0.2 molar. The reaction is that 1 mole of methylamine will require 1 mole of, I think it was HCl. Of HCl, and the HCl was 0.100 molar in concentration. Which means we need 200 milliliters. If I'm reading this right. Yep. You'll need 0.200 liters of HCl, or in other words, 200 milliliters of HCl to reach the equivalence point. Now, 20 is way before that. So that must mean I'm going to be in a buffer region. So I know that I'll be in the buffer region. And if I'm in the buffer region, well, no matter what, I've got to do these dilution calculations. So I have 100 milliliters of the CH3NH2. That is a 0.200 molar in concentration, and that is getting diluted to 120 milliliters for part B. So that is 0.167 molar. You do the same thing for your hydrochloric acid. You have 20 milliliters of your hydrochloric acid times 0.100 molar divided by 120 milliliters. And you get a value of 0.0167 molar. Now, looking at our reaction, we're going to take this methylamine. We're going to be reacting it with the hydrochloric acid to form the methylammonium ion and chlorine or chloride. We start out with 0.167 of our methylammonium, 0.0167 of our hydrochloric acid. Because you have a strong substance in place, it's going to go to completion. So we'll subtract out 0.0167 from both sides. And we will add that to our methylammonium ion. So looking at this, we have 0.1503 of the methylamine. We have none of our hydrochloric acid, and we have 0.0167 of our methylammonium ion. Now, Henderson-Hasselbalch is pH is equal to pKa plus log base over acid. We're not going to change that, folks. Just because we're dealing with a base does not mean you change it. You keep it the same. But that means I'm going to need to know the pKa, which means I need to know the Ka. Well, to get there, Kw is equal to the Ka times, which I noticed a lot of people missed on the last test, times Kb. Or in other words, Kw over Kb is going to equal to Ka. So 1 times 10 to the minus 14 divided by 4.4 times 10 to the minus 4. Yes. 4.4 times 10 to the minus 4 is going to equal my Ka. So the Ka is equal to 2.27 times 10 to the minus 11. So our pKa is 10.64. So now we have the information we need. So pH is going to equal the 10.64 plus the log of the base, which was 0.1503. Over the acid. Of 0.0167. And that comes out to be a pH of 11.60. Now, folks, does that make sense? What did we add? Acid. Which way did it head? Down. And it didn't go down by much because we are a long way from the equivalence point. We're going to stop and take the break early, and then we'll come back and do the last of these problems and then get to KSP. You want to walk around with mommy? I forgot to unpin you today. Go walk around. Let's walk around. Can you say hi?
Yeah, well, no, I figured I knew I was fun. So I'm not going to get on the long
I mean, either way, it's not too much. It's like,
and then it rains.
yeah.
You don't have to wait. It comes out.
He told my little brother where it was.
But she's gone like
So, I mean, it worked. The answer question you got property, which I don't know. But, you know, it's just
you're making me want to choose. So I don't maybe I need to go through my life.
There's too much going on. Just go and it's sitting by the water. It's better. Like I always go when my friends go, you sit.
It's chaos.
Right. Well, but there you go. It's not a, you can't go with it. So
Yeah.
it'll be
Everyone knows themselves. My mom has got a big bag of us. She doesn't feel like I do. So there was this road.
What are you gonna do?
Okay, sit back down. Back in your bed.
No.
That's true. It's
I'm kind of thinking about doing
I
that.
see.
Typically, you don't know.
Okay, let's get back to that problem. So our last spot said at equilibrium. First thing I would do is figure out what the concentrations are. So doing the dilution calculations for HCl, that is 200 milliliters times 0.100 molar divided by 300 milliliters. And for our methylamine, that is equal to 100 milliliters times 0.200 molar divided by 300 milliliters. So we're looking at 0.0667 for each of the two concentrations. So we have our methylamine, and we're going to react that methylamine with the hydrochloric acid. When the methylamine reacts with hydrochloric acid, the hydrochloric acid, being an acid, is donating its proton to form the methyl ammonium ion, and you're left over with chloride. You started out with 0.0667 of the methylamine, 0.0667 of the hydrochloric acid, and none of your methylammonium ion. As time progresses, because there is a strong substance present, you got to go to completion. So we're going to use up all 0.0667 of the methylamine and use up 0.0667 of the hydrochloric acid to make 0.0667 of the methylamine. And technically you are making 0.0667 of the chloride, but that is simply there to hold a, to make the compound charge neutral. So when it's all said and done, what you have is you have your methylammonium ion. Now that I should say that's not all you have, really. You have methylammonium ion, but what is the methylammonium ion in? Water. Everything's in water. So that methylammonium is tossed in water, which sets up an equilibrium to reform methylamine and hydronium. You started out with 0.0667 of the methylammonium ion, none of the methylamine, and none of the hydronium. You lose X amount of methylammonium ion, make X amount of methylamine, and X amount of the hydronium. So that at equilibrium, we're talking about 0.0667 minus X of the methylammonium ion, X of the methylamine, and X of the hydronium. Now, what is the methylammonium ion? Looking at this equation, what is it? It's an acid. Because it's an acid, we need the Ka for the expression. We calculated the Ka in the last thing. It was 2.27 times 10 to the minus 11. And that's going to equal x times x all over 0.0667 minus x. When you key that into the calculator, you'll get 1.23 times 10 to the minus 6. Now looking at what it is equal to, again, always go back and make sure you know what it is equal to, folks. In this case, that X is hydronium. Based off of our ICE table, that X is equal to hydronium. So we can go straight into the pH is equal to the negative log of the hydronium. So it's equal to the negative log of 1.23 times 10 to the minus 6. Which is 5.91. Questions? Yes.
Okay, so on that first equation that you set up with the 0.667, I know they're the same, but if they weren't the same, how would you know which one to subtract?
You always subtract out the lead. So first of all, you're going to focus on the side that has the strong acid or the strong base. So in this case, the strong acid. And then you're going to subtract out whichever one is in the least quantity. Other questions? Okay, then we're going to get into KSP, which I introduced last Thursday. SP stands for solubility product. If you break this down, solubility deals with solids. How soluble is a solid? Now the products piece deals with our equilibrium equation. Because if you think about it, every time we've done it, it is the concentrations multiplied together. And that's what you call multiplication as a product. Chemists are not really that inventive from a lot of with words. We invent in other ways, but words, Yeah, no. We're straightforward there. So we are talking about the dissolving of solids. Folks, everything you have learned, you're pretty much going to be using, even if we are talking about solid dissociation. So let me find my little short. This is a very short table of solubility products. It only has some common ones, but it's enough to get us through. You will be given the solubility product just like you've got to be given. You got to either be given the information to solve for the solubility product like you did in lab, or you got to be given the solubility product. I mean, you've got to have one or both, or one or the other. Okay, so the very first thing is you better become familiar with your ions again, if you are not. Because when you see a polyatomic ion, when it dissociates, it stays together. So let's keep it simple. Let's do something just simple like calcium carbonate. Calcium carbonate is a solid according to our solubility rules from chapter 8, I think, of last semester. Now, even though it's a solid, it doesn't mean, just because we say it's a solid does not mean there's no dissociation. Just means there's only a little bit. Calcium carbonate is going to dissociate into its ions of calcium ion and carbonate ion. Now, in looking at this table, calcium carbonate has a KSP equal to 3.36 times 10 to the minus 9. Remembering what equilibrium constants mean, because it's to a 10 to the negative 9 means it's a really tiny number. So we're not going to expect a whole lot of dissociation. Now we can write an equilibrium. Expression for our calcium carbonate, and our K would be equal to our KSP. Excuse me, would be equal to the calcium concentration times the carbonate concentration. And that would be equal, that would be our equilibrium expression for the dissociation of calcium carbonate. Now, so far, nothing big. Everything you should already know here. Solids, I mean, solubility rules tell you who the solids are. While solids don't dissociate to any appreciable amount, they do dissociate. They dissociate into their ions. You're writing a dissociation reaction. We can write an equilibrium expression just like we've been doing. We can interpret the equilibrium constant just like we've been doing. The only real difference is a term which you were introduced to in lab on Thursday. And that term is the molar solubility. The molar solubility is the molarity, the concentration of solid that dissolves. In other words, folks, it's our X. So we can take this calcium carbonate dissociation reaction and we can allow it to dissociate into calcium ion and carbonate ion. If we think about it from an ice table, initially you're going to have solid calcium carbonate. Now, if I recall correctly, they like to just put a line in place of the calcium carbonate on active. But you'll typically see me write it as solid. We have none of our calcium, we have none of our carbonate. As time progresses, some calcium carbonate will dissociate. For every one calcium carbonate that dissociates, you make one calcium and one carbonate. So at equilibrium, we actually have solid, we still have solid of the calcium carbonate. We've made X amount of calcium and X amount of carbonate. Using our equilibrium expression, the KSP again is equal to the calcium concentration times the carbonate concentration. So our 3.36 times 10 to the minus 9, that's equal to X times X, or X squared. So we take the square root of that. And you get a value of 5.80 times 10 to the minus 5. That is how much dissociates. This is the concentration of calcium carbonate that actually undergoes dissociation. Let's get it a little bit tougher. Let's go with lithium 3-phosphate. And I want to know, and lithium 3-phosphate, by the way, has a KSP of 2.37 times 10 to the minus 11. First thing we're going to do is we're going to take that lithium 3-phosphate, which is a solid, and we're going to write a dissociation reaction. For every one lithium phosphate, there are 3 lithium ions. And there is 1 phosphate ion. If we want to know the molar solubility, we start out with solid lithium phosphate. But and none of our lithium ion and none of our phosphate ion. For every lithium phosphate you lose, you will gain 3 lithiums and you will gain 1 phosphate. So you're still going to have solid at the end of the day. You'll have 3 times X amount of lithium and you'll have X amount of phosphate. Writing our equilibrium expression, our KSP is going to be equal to the lithium ion concentration cubed times the phosphate concentration. This is error number 1 I see students make. Or I should say error, actually this is error number 2. Error number 1 is they forget the 3 there. Error number 2 is they forget the 3 in the KSP. So our 2.37 times 10 to the minus 11 is equal to 3x cubed times x. Error number 4 is people forget what cubed stands for. Because 3 cubed is equal to 3 times 3 times 3, or in other words, it's 27. So this, folks, is the actual, this is probably the most common error. Finishing multiplying this out, so 2.37 times 10 to the minus 11 is equal to 27x to the 4th. So x to the 4th is equal to 8.78 times 10 to the minus 13. Now, for those that don't have an x to the 4th key, the way you take a 4th cube or a 4th root is you raise that to 1/4. And that's taking the 4th root. Now, if I can figure out how to do it on this computer or on this calculator. And I get 9.68 times 10 to the minus 4. That is the molar solubility. Folks, if you look at these two numbers, lithium phosphate at 2.37 times 10 to the minus 11 compared to calcium carbonate, you would think calcium carbonate's more soluble because it had the larger KSP. But in reality, lithium phosphate is actually more soluble as proven by the molar solubility. Questions? We're going to build on this on Wednesday. Like, what day is it? I don't know. Oh, me too.
How to apply for research. And so
Oh, great. Okay.
Because you told me to.
It's not hard. It's
Yeah,
just got to go online to do it.
Yeah, I just couldn't find it, but I finally I found the. You have to click on one and then
yes,
and then
it drops down research. Yeah.
I was like, okay.
Okay. Cool.
Bonuses. Are we using the same list as last semester for the
That's
food
fine.
pantry? So just like
yeah,
all those
I just like take in 10 things you like to eat. Yeah. You know, because if that's what's most popular is the things I like to eat.
Yeah.
So.
And then for the scientist one, are we adding a slide to the
yes.
PowerPoint?
Yes. In fact, well, there's a slide there that you can just fill in and go with
the
there.
2 examples that you already had on there, we just add our own.
Yeah.
Okay, and those will go in on the due date?
Yes.
Okay.
Anytime before or the due date, whatever.
And then we just email you the picture that we take whenever we put the food pantry
yes.
stuff? Okay. Sounds good.
I got where I didn't want to keep carrying it over.
Yeah.
That's smart. So on the, that's what we were talking about. You have on your ice table, you know the 3x. So then whenever you take it to your equation, you keep the 3 in front of the x and you cube it. Is there like a reason why, or is it just like how it is?
Well, I mean, the fact is you got to remember this 3 really is describing the concentration now. You have 3 times the amount of the lithium phosphate concentration. It's a number. You can almost think of it as a number. And the x cubed has to do with the equilibrium expression. So it's the fact that it's really just a number that's related to whatever dissociated. Which is kind of hard to think about, I know.
Yeah.
But that's why you got to do it.
I got you. See you later.
For the scientist thing, I thought I remembered you saying something about like we had to check with you that nobody else had done it. Okay, so I sent you an email. I don't know if you saw it.
Who knows when I've glanced at emails, but I don't know. When did you send it?
I think Thursday.
Then I probably haven't looked at it in length. Because it probably got buried. Who was, I'll try to look at it when I get back. I'll try to get to it when I can and let you know.
Okay.
So you do have to approve. That's what I was going to ask. I haven't emailed you.
Yeah, you got to let me know who you want because I won't take 2 of the same one.
Okay. When did I missed the first part of class? So do on like the
21st.
21st. My birthday. So just email you.
Yes.
I also have the first Child Talk picture of me donating stuff. Will that want in one email or?
You can. Hi, Kristin.
Okay, so I have a question.
Yes.
I have a new professor next semester. Her name starts with an M. I would say it's like Massard or something.
Massey.
Yes. Okay. Would you mind telling me a little bit about how she operates if you will?
Best bet is to ask somebody who had her. I'm trying to think of somebody who's had them. It's not, I mean, I will say in the past has used our homework system.
Okay, perfect.
But I don't know how she does it.
Okay.
And that she does.